history at Bahana College. And on behalf of the entire organizing team, I welcome you all to the sixth day of this online workshop on research methodology and academic publications, with special focus on the use of scientific tools and software. So in the last few days, we have had some engaging and thought-provoking sessions on the logistics, methodology, and the nuances of research and publishing. So I can only hope that our participants have been greatly inspired by the rigor and the scope of the deliberations. And I expect today to be no exception to the rule. Today we have two very erudite speakers with us, and it's my pleasure and my privilege to be a part of it. In our morning session, we are fortunate to have with us Mr. and soon to be Dr. Siddhartha Bora from the Department of Agricultural, Environmental, and Developmental Economics, Ohio State University in the United States. He will speak about statistical analysis of data using tools and software, with a particular emphasis on the software R. But before we go to him, I'd like to take this opportunity to introduce our esteemed speaker. So just hold on. Mr. Bora is currently a doctoral scholar at Ohio State University. He has an MS from the same university, where he was also engaged as a graduate research assistant. Prior to this, he did his BTech from National Institute of Technology, Warangal. His research interests encompass agricultural economics, applied econometrics, economic forecasting, and agricultural finance. His work has been published in numerous prestigious publications, such as Journal of Agricultural and Resource Economics, American Journal of Agricultural Economics, and Maternal and Child Health Journal. Of late, he has been the recipient of William E. Krause Director's Award in Graduate Research, Ohio State University. Mr. Bora will submit his doctoral thesis by the end of this current year, and we are positive that it is going to be a groundbreaking work in his discipline and in his area of specialization. So today we are privileged to have him with us, and I believe our participants, as well as the faculty of Bahana College, will be greatly benefited by his expertise. But before we begin today's session, I'd like to bring to your attention that, like the previous days, we have a specific code for this session also. The code for today's session is India, INDIA. I repeat, the code for today's session is India, INDIA. Note it down, as it will be required later. I'd also like to request our respected participants to please keep their microphones muted while the speaker is delivering his address. And if you have any questions for the speaker, you can type them in the chat box of the Google Meet interface, or you can address them directly to the speaker once he is done. And now, without further ado, I would like to hand it over to Mr. Bora for today's proceedings. Over to you, sir.
Thank you, Bikram, for the nice introduction. And I'm really feel glad to have this opportunity, and the organizers have provided me to share my experience using R and many other different tools for my research and any other work I do. So I would like to share my journey using different statistical softwares and why I do most of my work in R, and I would like to share some of the thoughts. So how it will work is I'll give a small presentation basically outlining how R is not superior, but what are the advantages of using R, and why I use R, and why you also might want to use R. And then I'll try to go through R interface and try to do some work in R, but it will be too ambitious to teach R in a 2-hour session. So I'm not going to try that, but just we'll do something using actual hands-on experience. So just I'll start with a slide. Can you see my slides? Okay.
I think you'll have to present it. You'll have to click the upward arrow button and then select which tab you want to share.
Do you see my screen now?
Yeah, now we can see.
Okay. Okay. So R is a general purpose programming language used mostly by statisticians, but it has many other uses. And R Studio is a integrated development environment which lets us use R. So this session, I will try to see what are the basic data types in R, how we can wrangle data using R, some visualization maybe if possible, and so how our Markdown, how we can write analysis, combine analysis and report writing the same place. And I have taken this some of the materials from Data Carpentry website. I provided the link yesterday in an email, so you can uh, look at their resources, which is geared towards social scientists. And the goal of this session, again, I have mentioned, is not to fully teach R to anyone, which because R is vast, and never try to do that. But it's aimed to encourage people to start using R if they are not already using it. I'm very sure many of you have been using some sort of analysis. Maybe some are not happy with current workflow efficiency, or sometimes people have repetitive tasks, which maybe suppose you are trying to create a map using some data. Maybe you have done using some sort of graphic software where you click something, and again next time you have to do some other map, you have to go to the same process by using a mouse, and then it's again and again. Suppose you have to create those map for every district in Assam, then you have to do it again and again every time. But when you do without clicking and say uh, use programming approach like using R, Python, whatever, it lets you really reuse your code, or doing similar tasks can really saves a lot of time for you and energy. So yeah, so that's what's the aim of this presentation is. So lot of mundane work we are doing in our research is not actually research. Many times we are trying to gather data from lots of different, say, files scattered over, say, CSV files, Excel files, which are fine, which are easy. At least it's a machine readable file. Sometimes it's in PDFs. Sometimes it is in scanned PDFs where you cannot copy paste from. Are there something automatically get the data from there? Is there is a solution in R? So my goal is to show people that if they have some problems in their research, there are some tasks which are difficult to do, they can find some solution in R if they know where to look. And again, we come from different disciplines. I come from economics, and I identify as an economist now. Although I have background in computer science because I have an undergraduate degree in electronics and computer engineering, then still different disciplines have their own domain in R. So there are packages which I do not know about. What are the packages in genomics or biostatistics? I do not know much, but I know the packages about economics. So many of the things I'll say today are coming from my experience as an economist. So it's very opinion. So because there are many ways of doing the same thing. So if I'm claiming that this is the best, so it may not be. It's just my opinion. Okay, so I have sent yesterday an email. So you might have installed if you are interested in working with R. So there's an R which is coming from a GNU. It's a GNU project. Like open source project, and it's a language. Then RStudio is a software which provides you the platform to work on R. You do not necessarily need RStudio, but RStudio is popular. It makes your life easier. You'll see why. And then, so we work using RStudio to interact with our compile our codes and all. Again, I have mentioned that the difference between working with Excel or sometimes say if you are using ArcGIS or even ArcGIS having codes, but some other GIS tools which lets you lot of the work using a mouse, then many other applications like that. The difference between those and doing it using R is you are going to write a long set of codes which will outline your thought process in terms of whatever task you're trying to do. It is set out concretely in a set of codes, and it will do the job for you. Then you can, if someone wants to do the same results, they can get using the same code. So only thing, if you want to give the person how you got those results, give the codes and they can run it and they can find the same results. Then also you can combine code and text together to generate reports, which are let you do it. So it's way cooler than just creating some figures from somewhere, copy pasting in a Word file. And again, if you have to repeat it, you have to adjust something, again do it somewhere, again copy paste. So this process, it's a improvement on the workflow that removes lots of repetitive copy pasting and moving files here and there. So that's the most benefit. I feel that it makes my life more easier if I do things using R than anything else. So in similar veins, it facilitates reproducible research in the sense that all the codes you have written to do the analysis can repeat the same analysis by another researchers, and it's basically makes your research very transparent, and anyone can repeat the same thing. So recently many findings have found that many researchers found that in earlier days, a lot of the even famous papers people now cannot reproduce because either data is not available, nobody knows what assumptions they have made because the code is not available. So it's less believable than people assume, even though papers are famous. So going forward, now many journals, especially the top journals, they need replication codes for publishing your research. Whatever paper you have written, you need the replication files, otherwise not accepted. So our codes are it's a very respectable way of producing replication archive for any research project. Then R is vast, so there are lots of packages in R. So packages are sometimes it's like equivalent to libraries in other languages. So what is a package is, say, suppose I am a linguistic expert and there are a lot of things, I don't know what they are, but suppose someone in linguistic, they might have some mathematical or procedures to say, do some word manipulation, and people have written some functions, R functions, and pack them together so that others can use it. So that's a package. So it's packages means collection of some functions in a domain which people can use for doing their work. So which are like very general purpose in that domain. So for many different, say for econometrics, there are a lot of useful packages. For time series, there are packages, and so I just install it and I use those commands. Otherwise, I have to write down a function of my own, which I do not want to do because it's just repeating. So as different disciplines have different their own functions, and many people are adding it. And if I know that many of you are coming from different disciplines, so you might want to see what R has for your discipline, and if not, maybe it's time for you to add. If there is something can be done in R, you can add it. So grow a community in R. But econometrics, especially in economics, GIS, these are like vibrant fields in R, and they have a lot of support, lot of packages already. And again, I earlier mentioned like one of my projects had data from 1980s, and those are coming from like lots of PDF reports, and I needed to get a working database, like just a CAV, so that I can run some econometric analysis. And that data I could not. I didn't. I was trying to hire. I was trying to hire uh, some people just to copy paste or just to do data entry, and it was expensive. Like so, once half we were starting the work, and I realized that I can actually do OCR reading in R. So because those they were in PDFs, but those are like scans, so I could not do some. I could not get the data into Excel directly. Then I could easily do OCR reading using R, and without paying anyone to do that, or within one day, I could get all the data, and my life was really easy. So in R, you can use, if you have a simple CSV and Excel, fine. But most of the time, we do not have so much good data or clean data. But using R, you can get data from a database like if you you do not have to know a lot of SQL to interact with the database, because lot of the R functions does the similar things as a SQL database would do. Then you can interact with some APIs, and then you can do web scraping. Web scraping is something like I get data, I write some code, and I read automatically some web pages and get the data from there and do analysis there. So using R, you can gather data from anywhere as long as it is in electronic form. And also R provides a lot of data wrangling and cleaning tools where you can get those messy data into some sort of data which you can actually analyze. Then there are a lot of very cool graphics features in R. I personally like Ggplot too. Now everyone likes it. Like in past few years, it has taken like over the base R plotting features. Like R, when you install without installing any additional packages, it has some graphic features which we can plot, but those plots are really good. But Ggplot 2 is something like a layered grammar of graphics, and where you add elements of a plot one by one over other, and overlay it and create graphical elements like that. And then there is something like Shiny, which lets you create web apps and which are interactive, like an app. And the funny thing is, to create an app, we do not really need to be a web developer or something. You do not need to know a lot of HTML and whatever CSS technologies that the person needs to create a website. But using just R, you can create a passable web app. And another issue is that okay, how I learn R. So I had been using different types of softwares to do analysis. So I started with MATLAB when I was in my undergrad, because a lot of the analysis that time is computational heavy, and at that time I was using MATLAB, and some of my work has been in MATLAB, and even I use MATLAB, and it has its own use, and it's used for some when I need something very computational heavy, I use MATLAB. But sometimes when things are very, I need good visualizations, then I move to R. Sometimes even when I do analysis in MATLAB, I do the visualization in R. And the best thing about R is I learned R over time and did not do any courses or something, but I started doing whatever I wanted to do using R. So I already told that the best way of learning this any software of data analysis is not to go through some courses or say workshops. Workshops also fine. Just kidding. The best way is to find out what you have to do. Like, okay, today I have to draw a graph. Let's do it using this R. Can I do it? So initially it will be not fast, but over time you can you will pick it up. So that's the best way of learning this. But the problem is you often get stuck in some small issues, and that time a community can help you. So our community is really vibrant. So the Stack Overflow or anywhere RStudio community, you can write answers, questions, and somebody will answer it. Or someone already asked that question mostly, and because people have tried the same thing as you before, and you can just get the solution right away just by Googling. So mostly they are, if you have a problem when trying to do something in R, you will find the solution quickly just by Googling how to do this in R or something, or just typing the error message in Google because somebody figured it out. And again, it's free and open source, and which I really like, and also it's some sort of like ideology, like open source revolution. And I do not want to compare or compete with other softwares, but there are softwares for which you have to, for statistical analysis, there are softwares you have to pay a lot of fees, like thousands of rupees or dollars per year. And for R, you do not have to pay anything. And also, you can adapt some. Suppose there is a package in econometrics, which is fine, but I do not like it, or I just want to add more to it, and I want to use it myself. So I can modify the code because code is available. I can build over it. I can fork it from GitHub, and I can make a new package and I use it myself. I can even release the package myself. So nobody put a copyright notice on me, as long as I respect whatever copyright notice they have given, which is mostly very lenient. So free and open source is one more thing. And also another thing is, if people are familiar with version control, there's a website called GitHub, and there's a software called Git, where people track different versions of their work and also collaborate with people. So our studio, our files can be tracked using Git like anything else. We do it using Git, but our studio also has a Git interface, graphic user interface, which where you can use Git just by doing some clicks. So it makes life more easier. Also, when I open RStudio, then you can also, if sometimes you need to use C and Java within R, you can easily do it because there is interface for that. And also, like I mentioned earlier, using Shiny, you can create web apps without knowing much HTML or any other web technology. Because R is some sort of a intermediary between them, when they want to interact with them. And okay, so I earlier mentioned, so is it really difficult to learn, and how long it will take, assuming that people are complete beginners? So it depends. So how to learn is just try to do your stuff using R. So day-to-day life, like day-to-day research life, you need to do a lot of different things. Many things comes up, and if you can do something in R, next time you want to do something, you do not have to do much, because you can adapt because once you did something, the code is available. Suppose you want to draw a box plot. Okay, it's fine. You have drawn it by figuring out how to do it from different websites. You wrote the code, but now you have the code. Next time, first you already know how to do it, so you remember some things from earlier, so you do not have the same problems with the and and you can just repeat the code and produce the same graph. Suppose earlier I was mentioning, so suppose some map for Jorhat district, you were supposed to make some population map. You made it using R. It took a lot of time. Okay, it took 1 day to do whole thing, but next time you'll just do some modification for creating a map for Golaghat, and it will be done in 5 minutes. So it accumulates, and over time, like you figure out doing different things. So if over time, like say 2 to 3 years, you already did a lot of things using R, because you had to do a lot of things over these 2 years, and suddenly you become an expert in R in your domain, because you have been using R. So the what I'm trying to convey is the process of learning R or any other statistical software is accumulative, and it happens over time, and it's mostly done by learning by doing things. And since it doesn't matter to us what programming, basically it matters to us what is being done. Basically we want the work is done, so how we do it doesn't matter. But if something helps you do it less time and more elegantly, it's good, right? So that's why using R, it might help people to increase their efficiency. And one quote I read somewhere, like programmers, like say computer scientists, or suppose just a coder. I'm not saying for computer scientists, they have also a domain, but just a general coder. Uh, it, it is fine. People can write codes for doing something, but it doesn't do much. But suppose a subject expert in something, which every one of here are, someone like Bikram is from history, some Pankaj is from political science, and many I am from economics. But we just add some programming to our work on top of what we already know, what we are experts at. We actually can make ourselves much more efficient and uh, be better in our actual work. So if domain experts in different domain can add programming to their arsenal, they can do wonders. That's actually I have experience when I work with my peers. Uh, as an economist, I have same domain knowledge, but sometimes these skills kind of differentiates. Uh, being from a, although since I also come from a coding background due to my undergrad. Okay, resources. If you want to learn R, there's a book called R for Data Science. If it is first book about R, it's free. It's in a website, and you can read that book and know, and you can start the journey from there. You will figure out other things over time. And there are a lot of videos and courses available. There are lots of blogs and websites, and mostly Stack Overflow, and you'll find answers for different R problems. So if any questions regarding anything about R, you can email me at bora.19@osu.edu. And at this days, I'll just stop for some questions because I finished my presentation. And before we start some artwork in our studio.
Thank you, Mr. Bora. Am I audible?
Yes.
Yeah. So, thank you. And that was an engrossing and scintillating session. Although I'm somewhat familiar with the rudimentary basics of programming, my acquaintance with R has been very recent. And as I have to crunch a large chunk of data, primary data, for my doctoral work, so I'm thinking of giving R and R Studio a go. So in today's session, Mr. Bora demonstrated how to handle and maneuver large piles of data using R, which is a GNU license project, and R Studio, which is an integrated development environment. As he put on record at the very beginning of the session, today's goal was not to teach R, but rather to motivate teachers to use R for its seamless experience, its workflow, efficiency, and most crucially, as a respite from the mundane and cumbersome repetitiveness of handling data. Not to mention how it saves time and energy. So by taking a hands-on like approach, he showed how the best way to learn a software is not via a rigid straitjacketed learning scenario, but to learn on the go. And of course, self-learning may lead to many hindrances, but that can be overcome with the help of a vibrant and dynamic R community, as you mentioned, be it on Stack Overflow or the World Wide Web in general. And of course, considering that it has a GNU license, it is a free and open source platform, which I believe serves two crucial purposes. First, it is a boon for researchers in the developing world who might suffer from an acute shortage of funding and resources. And second, the code can be tweaked and customized as it is open source, so which I believe sometimes suits the requirements of different users. So I thank you again, Mr. Bora. I'd rather say soon to be Dr. Bora for this wonderful session. So now we are open for questions. As I had mentioned before, the participants may either directly uh, approach our speaker, or they may type their questions on the chat box. So we'll wait for some time for questions, and then we'll try to wrap it up.
Yeah, I just mentioned that comment. I remembered the when I started using R just because when I graduated from NIT Warangal, I lost my MATLAB license because I cannot pay for it, and it is expensive, and I needed to use MATLAB for some purpose. Still, I have nothing against MATLAB. One of my recent papers is entirely done in MATLAB. It has its own uses, but suddenly I was working as a consultant, like freelance consultant, for some time, and that time I did not. If some of you also might do similar kind of work, I could not afford license, so I lost my MATLAB license, and I needed something to do my work. Then I figured out about around in 2011. Oh, there's R. It is free. I was like, oh, is it good? Then uh, then I saw it's as good and as powerful, and then I never looked back from there. Yeah, it's been like more than 10 years. Yeah, if any questions at this stage.
Can we keep the question and answer session for a later half, and we can go for a practical one?
Can you go for the hands-on practical?
Okay.
So Mr. Bora will now approach towards a practical, or rather say hands-on approach to the R development environment. So if the participants have any questions, I'd ask them to hold their questions till this practical session is over. Over to you, sir.
Do you see? Do you see my R Studio screen?
Yeah, it's visible.
Okay. So if any one of you has installed R Studio and R, you can try you opening your R Studio in your system. So I'm using a Windows system, and here R Studio looks like this. So when I open it without doing anything, so it says R version 402. So it's the most recent version, I think, as of last year. I might not have updated after that. I'm not sure. This is this on towards the left where my cursor is. This is called console. Here you can do small calculations. You can do you can write your commands basically. So I am writing something called a equal to say 2. Okay, what it is, I'm creating a variable a and assigning a value called 2. So this operator, like a arrow and this arrow thing,
Sir,
this
can
is
you zoom the screen so that we can?
this is
If you
actually
zoom on, then it'll be more visible. I mean, like more clearly visualized.
Yeah, yeah. If you can zoom it, then it will be like clearly visible.
is it okay? Is it better? Okay.
Yeah, perfect.
Yeah, little more will be better. Yeah, yeah.
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 Okay.
Now it is good. Thank you.
So yeah, so we can keep on doing some things here, like b equal to 3. So what I have done is here is like created two variables or objects. A has a value called 2, B has value 3. Just like any other software, you might have done these kind of things everywhere. So here it is called console, and here you can keep doing your analysis one command at a time or set of commands at a time. But you have to enter once you have this cursor. Now, where these values are, so you can see that in the right side, there's called global environment. Currently, in that environment, there's A and B. It shows that its value is 2 and 3. You can create something C. It gets updated. So it shows what are the things in your environment right now. So if you are doing a big sort of analysis, it is not necessarily going to be that simple, but it will show you what are the things you already have. And also here it shows your computer files where you are currently. Currently I think I'm in my documents, so it is showing a lot of different things. If there will be some plot, there's plot, and it shows the packages you have. You can install new packages or update new packages, current packages. These are the packages, different like thousands of packages I have, depending on what I use. So you might have to install it yourself. And there's help. So for help, you can find out things about different topics. So you can search here. And yeah, so it gives history of commands. Sometimes you want to look back. So this is the look of R when you open it. Now, when we do analysis, we don't really do things in console, although small things, if I just want to, if I import some data and just without trying to create a large analysis log, we are just trying to have a look at it, the data. I'll do some things maybe in console, but mostly we create a script. Okay, now you can see that A has been assigned 2, 3, 4. Now you can use this A and B to create some new things like multiply A into B, give 6. So it stays there. Whatever things are in global environment, you can use it in console once it there in there. But we do not do analysis mostly like this. The correct workflow is we create a R package. Oh, sorry, project file. We go to new project. I don't save what I was currently doing. Don't save. new directory, new project, test project, say, okay, our workshop. Oops. Let me keep this in my desktop. Okay, this directory is not there. My workshop. Okay, once you create a project, what the project does is it creates a folder for you, and now you will start creating scripts. The script is something you will do the same things you are doing in console, but you will keep it in a file. So if I type these things, a equal to 2, b equal to 3, here c equal to 8, a d, d is equal to m a multiplied by b. So these things are not being calculated. These are just writing in a text file and it is not running. You can run by selecting them and typing the run here. So then it will, everything you selected will run. But this file you need to save it in the folder my workshop I have created. So this is called .r file. It will end this like .r, like .text file or any other file. Say script 1. So this is the file. So these are codes. These things run when you run this, and it is run as if it is whole lines are written one by one in this console. So that's like this. You can keep doing analysis, create a lot of new things, and do your analysis here. Now these are like very simple variables. Like it has only it is having only a scalar value. Like scalar value in the sense there's only one value. You can create variables name, say it's called vectors. Can have more values. So this d, if you see what print, if you see what is in d, so if you type just the variable here, it is a variable, so it's here. The earlier ones are like 2, 3, and 4, but here it is numbers 1, 2, 3, 2, 3, and 8. It is a vector. So it has multiple values 2, 3, 8. So it is used to hold long sequences, like say a lot of dates or the price of stock, things like that. Again, you can create another say new variable, repeat 10 times. So if you see like d2, it is having a repeated d2 2 times. d3, these variables. These are all vectors 1 to 10. So you can create something like, again, you can see like these things are getting changed in the global environment, and this d3 is 1 to 10. So these are all vectors, and you can use this in your calculations, and you say want to say once like years, I want to get 20 years from now, 2021 to 20 years. I'll use it as a plot. So here you can see that variable year. So year is showing value 2021 to 2040, and so these are vectors, and you can access. So if you want to get these year variables, only the first 5 data. So you can just select like this. One thing you can see that when I select and run, only these things will run. And if I save, these things resides in that folder. So that this and this, you can see that this is called .r. So yeah, so one more thing, you can write comments. So this is sharp is the comment. This thing does not run. Just explaining vectors in R. So if I try to run it, it doesn't do anything because it's just a command. So it's a good practice to keep writing things in between so that people can understand what you are doing. So basically, when you are analyzing something, suppose you are doing some population data. Typically, what you will do here is you will try to read the data, get the, here I'm generating my own data, giving my own 2, 3, these are random numbers, right? So one analysis, also some analysis on some work. So here, you will read some data and keep on doing some things like this. In between, you'll write some comments, and maybe at some stage, you'll write some plots, and maybe you'll save these plots in some file, and then maybe you will output some things, and this script will remain as a record of analysis. Typically, this is the most commonly used R file in R. So how the people does it? So let's close this. Don't save. I don't want to save this. I want to show you. So I had been working with this project. Can you see a folder in my laptop? Like R social science?
Yeah, it is visible.
Yeah. So what? So this project is named R social science. It's in my desktop. When I was creating a R project, it creates a folder and it has this named file called R project. You can see the type like R project. And if so, these other files I have created, these are .r files are some scripts I have written to do some analysis whilst I was building this. And this is actually one RMD file while also to create the slide in using R. The slides I showed, although these are not fancy slides, it did not have any visuals or something. These are created using R. This PDF was created using R. So I actually do not use PowerPoint. I use R to create my slides. So you can actually have these codes if you want to see how it is done. So I was working in this R project. I created the R project using the same methods. Now I have closed my work because now tomorrow I want to start working on it. So if you created the R project, once you close it, once you want to open it, go to that folder. You can click on this, then this project will open. And in R Studio, you can see that what is new here. The new thing is, if you've seen the files pane, it will show where are you. Earlier, it was showing my document, but here it is not. It is, you are inside this project, you are seeing the project files. So in that project file, I have written some codes and I have created a lot of different work. So let's see my work. Okay, I was trying to do some data wrangling using some data on African irrigation and people's food security. Let me go through this. So I do not want to type one by one because it is sometimes boring and it takes a lot of time. So I'll show you already written code a little bit. So this is how a typical analysis looks like. Okay. Now there's a call live. There is first commands are we need to load the libraries. Library in the case packages. So if I want to load this library called tidyverse, tidyverse is a very popular R package. Ggplot is a part of it. If you just put this command in your system, your console, or just run from here, I already running this from here. For me, it runs and it gives me some packages. Because I have already installed it. But if you have not installed it already, if you try to write this command and run it, and if it gives an error message, you need to install this package. So install, you have to write something like this. So if you cannot load this library into your R and it does not work for you, for me it works because I have installed this package called tidyverse. You need to install this package. So this is the command like install.packages, and you can give the name of the package in quote, and it will install the package, and it will show in this packages folder. If you do not have a package, you can install it. Means if you are going to use it. So before using any package, you need to use this package. You need to use this library command to get the packages in your memory. Now, one more thing I wanted to show you is like you can see RStudio. Why RStudio is good, and you are trying to write some command like I'm trying to. It helps you, like you do not have to remember a lot of things, so it helps your learning process. You do not need to remember a lot of commands. Basically, RStudio helps you complete your commands. Then, so this read CSV. So here I'm trying to load this. There is a data set. So if you go back to my folder, you can see that there is a folder called data inside my R social science, which is my project I created earlier. So there is a folder called data, and inside that I have this Excel sheet or CSV. So it is, if you click on this, I think you can get this data following the instruction I sent yesterday. It's towards the end of that email, that link in data carpentry. So I did not send you this data set because it's in data carpentry, so you can get it directly because I did not want to transmit myself. So it's a data set like many other data sets we have. This is data sets coming from some population data, and this is like some villages, households. Households are interviewed, number of members, years, I'll live like their ages, their years live in there, how many years they have lived there, I think. Okay, doesn't matter. And their house types, number of rooms they have, member of some association, if they have, what are the items they have, and like, but that item is like one by one. So it's a weird data. And then some of the months where they do not have food. So this is something about irrigation and their food security, which months they do not have. So it's a data set we'll try to use for our work. So the point was, so inside this folder, I have this. So I need to get this from into R without doing anything. Without doing anything in the sense that I do not have to load the data directly. So there's a command for this, which is coming from a package called reader inside tidyverse. This is called read CSV. And you have to put the name of the, so you need to give the path. So it assumes if you see the files pane, it is called current working directory. Your current working directory is this, you are inside this package. So you just have to start with this data folder and then name of this file .csv, and if you want the NS or not, missing data. So if you run this, currently you can see that it's just the codes, it is not being run. So global environment does not have anything. So if you run this, okay, so it is giving me a warning because I'm trying to install it again because I already have it. So I install it again. I will not. So what I did is I commented out that part. So this, if you put the comment, it won't run. So if I run this, you can see that there is now a variable called interviews, and it is 131 observation of 14 variables. So which is something called a data frame. So without clicking anything, just by running a code and giving the path of where this file is, you get the data here. So interviews, if you put here in your console, you can adjust the, if you just, it's just like those A, B, and C I wrote. A was 2, B was 3, like that. But here interviews also a name, but it is use. It's the entire Excel sheet. You can see it cannot show everything. So it is just showing some of this, whatever we had in that this thing, but it does not have space, but it's seeing that more things are there. But to view it, you can view using, you can see that RStudio is helping you to write it there. So here you can, the viewer lets you see it well. So you can see that, okay, this Excel sheet is here now. Now we can do things using it. You can see that everything is there. So ID, village. So this is villages. So interviews. So this interviews data is called a data frame in R. So data frame is something like an Excel sheet where there are columns. Columns are variables, and rows are every case. Like for, in this case, one row is a household. Now you can view. Now you want to just see things in different villages. Suppose you want to see what are the village names. There's a command called unique. You can see interviews. There's ampersand. If you put the ampersand, you can get, not ampersand, $sign. You can get the, you can see that it shows you all the variables they have. And for village, there are 3 villages here: God, Sirojo, and Ruaka, some African villages, Tanzania, I think, or Mozambique. Now you can see that there are 14 variables, and if you want to work with only some of them, again, you can see what are the column names. There's something called column names, call names, interviews. It shows the column names because you need these column names to work with. Basically, you'll refer to these names on the top of this Excel sheet. Now it is no more Excel sheet, it's data frame. You'll refer to these data names. Every name is variable name, and use this to write codes and to do some things with it. Now, say you just want only from interviews, you only want village, number of members, and months select food. So there's a command called select, and you have to get the name of the things here. So if you run this, again, you can create a new variable like this. So this line here, this command, this arrow here, what it does is whatever done on right hand side, the result is put on this variable interview. So that's why when you run the data, read the data using read CSV, it's a function in R. Its function means it's set of commands which does a thing. So saved in interviews, and interviews is created here. now if you run this, interview is same. Now if you run this select, and it is doing something, but there is no assignment, there's no new variable creation. It runs, it creates something here, but it actually does not change whatever has been in your variables. But it has, if you want to store the results in, say, interviews 2, you need to create a new variable and give this, assign this value, whatever new dataset you created, to say it's a name, it's just a name, you can give any name. So if you run this now, you can see that it has changed. Now interviews 2, and it is 131 observation of 3 variables. Now it only has, you can click here, it will open here like view. So now it only has 3 variables. So you selected some variables, you can, interviews has only some. So it's simple, like it's a command called select. You have to remember this, what is the command to select some column from a data frame. So it's called select. So it's very intuitive. So how to select, it is select. So you don't really have to remember things. Again, I want to create say there we knew, right, there were only 3 villages, interviews, village. So there was one village called God, Shiroju, and Ruaka. Now we want to filter. The command for filtering is filter. And suppose we want only the village called Shiroju, you have to write the command filter interviews, village name equal to Shiroju, double equal. This is important. And then it will create only, it will keep only the village Shiroju. Now you can see again, there's nothing created here in global environment, nothing, because this filtering result is not assigned to a new variable. So it is creating something in the console, but not actually being stored in the environment. So suppose now I want to create Shiroju data, subset data. Now I give, let's create this variable. Now you can see that this, now it creates Shiroju data, because now you can see there are actually 39 observations of 14 variables. So what is the difference between these 2 operations? Select, what it did is it only took some columns but kept the same rows. So I selected some variables but did not delete any case, like any household. Here all the variables were there, 14 variables, but only the Shiroju data, 39 houses from Shiroju were kept. So if you click there, so these are common operations we often do when analyze this kind of data. I actually worked with a lot of projects before joining my PhD, which collected a lot of population research data. I worked in a Gates Foundation project in Uttar Pradesh. I almost visited all the villages there, collecting almost this kind of data, cleaning data, managing survey teams. So most of the data are like, I think many of you are doing this kind of analysis. So here you can see that in this data set, everything village is Shiroju. This is how, so the thing is, the command is select. To select, command is select. To filter, the command is filter. So the point is, these are very simple commands, easy to understand, and also RStudio helps you to complete the code. So it's actually faster than it looks to do the analysis. So there is smaller things, say you can select interviews from village Shiroju, number of rooms more than 1. So rooms is a variable. Number of rooms more than 1, number of meals per day more than 2. So if we subselect this, Shiroju say 2, you can see that this data, Shiroju 2, only 10 are left because I have put more filtering commands, like people from village Shiroju with more than 1 room and number of meals more than 2. So these people are only 10 now. So we only have 10 variable people here, 10 houses here. So now this way, like we can filter, select a lot of different things we can do. We can, if you want two villages, village Sirojo and village Ruraka, we have to give this OR sign. So OR command. Both villages will be there. So like that, we can do a lot of filtering, selecting, everything like that, and we can get the data in a way we like. So that's what I have done in a different project or different data cleaning. So what I did is here. So I wanted to create some graphs there. I took this data and created another data for plotting. So this is step by step. Okay, one more thing is you can do these things step by step. Now, what I want here is I go back to interviews. Everything is fine with this data. It seems if we go to the data, it seems good. This is like maybe key of the village name, interview date, number of members. This is good. Years living. Okay, this data, if you see, some member of association, some has NA. NA means no data, or they're not. No, yes, no, and no data. NA, you know, if you do analysis, NAs are bad things because you do not have information. Affected by conflict, once, never, NA. They did not answer that question. Maybe it's a somewhat confusing question or something. But this thing, items, what are the items you have? This is like words. So you know, words, if things are in words, not in numbers, it's difficult to analyze things. So, and the number of words in every variable is not same. Like here, bicycle, television, solar panel, table, there are a lot of cow carton, different things. So this is a massive variable. So I want to do something about it before I try to plot some things. Again, month select food, it is also a problematic variable. January, so some different months. So what I want to do is I want to split this variable, split in the sense that I want the variable for bicycle, yes or no. So like this, member association, are you member of something, yes or no. I want, do you have a bicycle, yes or no. Do you have a television, yes or no. Do you have a solar panel, yes or no. Then for January, did you have food in January, yes or no, like that. So that is better in analysis. So I want to do this thing here in using this data. So that's what I did using this data. So as usual, I get the data from my folder. You can see that it's coming from this folder. Just you have to give the path, and using this read CSV function. There, one more thing is, like earlier we gave like select interviews because we have the data in interviews. After that, I gave the columns, say village, and then I wanted to filter interviews village equal Surojo. Village and PID, say. Oh, I forgot the column name. What was the column name? So I'll look at column names. Interviews. So that's why this is useful. So I remember like PID. Okay, this is the variable. So what it was doing, first one was doing, it was creating only two variables. I'm not creating new one, but just showing it only have two variables. Second operation, filter, is keeping only Shirojo. Now you want to combine these two. So you want to do these two operations one by one in the data. So the way to do it is to pipe. So there is an operator called pipe. So I will start with interviews. So interviews is there. So first I want to apply this selection operation. Selection operation in the sense that I just only one village and key ID. What I do is select. I do not need to put interviews anymore because it is taking from here. So it is operating on the select village and key ID is operating on interviews. So if you run only up to this point, it will do the first job. And after that, I'll operate filter. So again, you give a pipe like that. You stack on things you are doing. So you build on things. So if you run up to this point, it just does one thing, like keeps only 2 columns. Then I put the filter operation. Then this creates only village Sirojo. You can see, and only 2 columns. So likewise, you can keep building on doing some new things one by one on that data frame. This is called pipes in R. I know that it's been overwhelming because piping is something I learned in 2015. Although it came around 2013, Ggplot and this concept of pipes when I started using R in 2011. So I really jumped to it, but this is so I'm sorry about that. But the idea is just I wanted to show the idea of analysis which is different from other software. So what I was doing using select one by one is being done in other software. Like you use say you did something, you create a new variable, then operate on something. Here what you do is you stack up on things like interviews data is fine, then you do something, then do something. You still do not stop it. So you can the result of the whole thing, then you can assign actually new data, say new variable, new var, or I give it's customary to give a name that means something clean interview, say. So see that something called clean interview is created here, 39 observations of 2 variables. So this way you can see in my analysis of the whole data, I have been creating interviews for plotting, starting with interviews, and I'm piling up things one by one. So separate rows. So this separate rows command, what it does, separated this item on to using this colon. Then I am then replace NA. So this separate row is a function. So it is a name is intuitive. You do not have to remember. So you just need to know that there is something called separate rows to separate a. So what I'm talking about is I want to separate these things into different columns. So if you see, so it starts with interview. If you run up to this point, this interview plotting does not have anything. It does not change anything. It's just the interviews thing. So if you run up to this, in this case, I separated that item zone. Where this interviews plotting is, you can see that items own is separated. Only one is there, bicycle. And it actually created 631 entries actually. So it created duplicate rows for the same variable, but it actually separated that variable in that item on. So there is now, instead of 131, 631 entries, because there are 631 things that people have. Although different households might have different numbers. So likewise, replace NA. Replacing NA means not applicable. When there is no listed item, I'm replacing this NA as there is no item, just to give a name. Then there's a command called mutate. Item own logical true means I'm creating some new variable where it is true. Then there is something called pivot wider, and there's Okay, I do not go about this. What I just try to make home, because these are some complex code here, but what I'm trying to make home is, the point is layered way of thinking, and over this process of doing different things on the same data, you finally arrive at, after running everything, you finally arrive at a data set which now have bicycle, true, false, true, false, television, true, false, solar panel, true, false, motorcycle, false, true, electricity. And for January, September, October, November, December. So this is what we wanted from the data. So because this data, Mons Lake food was not good for analysis. It has some words, what we can do with words, to how we can create things from words, like graphs and words, very difficult. Item was also a very messy data. But now interviews plotting using true and false things, we can actually make some graphs to do things using this data. So this is one example of data cleaning, where what you can do in a, I did not mean to show you like all of the codes inside this. Just I wanted to show the process of cleaning a data to get into an analyzable form in a numeric form, because that data of that item zone was not numeric, and you cannot do, if it is not numeric, it's difficult to do any analysis. And the process is layer by layer. You do one thing, you pile up on that, and finally, after a lot of processes, you get into your end product. Then once you get this, okay, you go, now there is interface plotting. This is the data. Now you can actually output the data. So now I want to write the data into a CSV file. So this CSV file can be generated from R. So let me delete what I already have. I already did it, so I'll delete it. So there's no data there. You can see this write CSV. It is taking this variable interface plotting, which has this whole 131 observation of 45 variables. Why there are 45 variables? Because some variables, many variables are created. From months, there were 12 new variables, because January to December. And then those were different objects. From bicycle, we created a new variable like that. So now it became 45 variables. Now I want to put this data into a new file called interviewsplotting.csv, which I do not have right now. But if I run this, it will appear there. It does not show anything because it is not outputting anything to console, but it is actually giving out the results here. You can see the time, shows my time right now, like 1:48 a.m. So now we have a new data set there, clean data set. Okay, this is Cephii clean. So interface plotting, you can see that that data was clean, then created like objects were separated from there. So this one, we just saw how you get data into R, clean them over different things, and then do plotting. Then do writing the data into new files. So this is the point I wanted to make about analysis. So only point I make it, I did not want to like paste all the commands inside, but just I demonstrated that there are operations, there are functions like select, filter to do a lot of common things you do in data. And there is a way of doing a lot of different cleaning operations one by one to get the data in a way, in the way you want. Now I'll just demonstrate one or two graphs using that data, new data I created. I think so. I already have some codes. Okay, I was trying to do this graphs, Ggplot to graphics. I gave the name of that file. Now again, it's custom. Although I have already have this library tidyverse in my memory. Memory means our memory. So I'll still type. It's a separate script, right? Script in the sense that these dot R files are called scripts. So it's customary to write library command to load the script for every script where they need it. So I got the library. Now see, let me clean this. Oh, there's a Jaru here. So if you just put this environment is empty, like it is gone, everything is gone. You want to start new analysis. So here, I want the new data I just created right now. Same command, read CSV is coming from Ggplot. I run this. It gives you some warnings, which are shows you some things about this. Again, it's the file we created, 131 observations from 45 variables. Okay, and now again, the plotting also follows the similar thinking of layering over one over other. So we start with this data frame. The other data frames are gone, so just remove this. Okay, you just want to open it. Okay, it's still here somehow. Okay, so this data frame we want to work with, and we want to create some plots. So the package name is Ggplot2. You can read about it. The idea of layered camera of graphics. So the idea is whatever we create a graph or plot, it is different layers over one another. So you just want to create one item at a time, and everything taken together will create your graph. Like currently I have this. It's just a data frame. Now Ggplot is the command for this. AES means aesthetics, X means x-axis. So I want to plot number of members, y-axis against number of items, and a geom point. After that, point means scatter plot. So it draws a graph of number of members against number of items. It's a scatter plot, like 5 members and say. So it shows that if many members, they have more items too. Maybe there is a correlation. Otherwise, it's a scatter plot. So the way to run it is, first, this data frame. This is not a graph. So let's remove this. Currently, there are no plots. So at this point, there are no graphs. It's just the data frame. Once I have a pipe operator, up to this command, there is nothing. If you run up to this, there's this graph element. So at this point, I just told you my x-axis has number of members, y-axis number of items, but I did not plot anything. I just created the frame of my graph. So I'll layer by layer, I'll do things. So for graph layering is plus sign is similar to this pipe. So after this, if I add this geom point, it will do a point like scatter point, geom point, geom bar, so geom count, things like that. So okay, still this aesthetic was like really does not do anything here. Just this graph does not tell much. So if this AES only had X and Y, you can add color and color by village. So if you put color equal to village, so there were 3 villages, right? So there will be separate colors for this. This dots will be colored. So if you plot up to this, so I just add color village here. It is still not plotting anything because I did not say which plot. Here there was geom point. So if I say geom point here, let's see what happens. Only difference is I added color village here. forget about this geom count. You can see that these are colored by villages, and it also shows which villages has which color. So it's just one way of telling just color by village. So this aesthetics, the point is up to this point there was nothing. It just sets us up for starting to just sets up the figure area and prepares us to draw the graph. After that, we draw a point graph. Okay, not point. I want to point something different. Geom count. So geom count, geom bar, geom point, different types of graphs like bar plot, histogram, things like that. So geom count, what it does is it makes the dots large size as the number of uh, people are there, number of households are there of depth. Okay, so like this you can create box plots. Say you want to put the responded wall type, wall of house against number of rooms, and again up to this point there will be no new graphs, just nothing. It just sets up the things like x-axis is wall type, y-axis is rooms. But then I add the geom box plot. It will now plot box plot again. When I select these things and run, only these things are run. What I'm selected, so it also appears in here as if I have copy pasted there in console. Like that, you can plot bar graph. So I'm showing it separately just to see that different graphs can be drawn. And geom bar just shows it's a graph, a bar plot. But you can actually, in the bar plot also, you can put different aesthetic. AES means aesthetic. Fill means fill means what color should be this fill of this bar. Then by village, like those dots, we color the dots. It will make these fields by village. So it shows the counts of these villages, wall types, wall, barn bricks, cement, mud daub, sun bricks. Yeah, so Sirojo village has very low sun bricks, like this. So this is separately I'm showing things. Like this way, say once I also created a variable using the different earlier approach. Like I changed this interview plotting to a percent wall type. So from this interview plotting, like the whole data set, I'm trying to create a percent wall type by removing filtering not equal to cement. This is not equal to, I don't want cement walls. Count the respondent wall types group by ungroup. So this process, what it does is it gets us a new data set. It's very simple. So it is just the whole process. That's the point actually. You can the material I tried to show you here. I don't think it is much of help. I am working here right now, but it is available at Data Carpentry, which also has a lot of interspersed comment and description. It takes about 5 hours to go through this. If one fine day you feel like it, you do go through it yourself. It will help you much better than the thing I'm doing here. I just wanted to show you the idea, like what can be done. So in this, so I'm very sure that not many of you I'm not being able to explain it everything, like what every commands. I just want to show that what can be done. So here, my apologies for trying to be very ambitious in going to like this Ggplot and all this. These are kind of intermediate R topics. So This interview plotting, it is a huge data frame. You see, it has a lot of data. From this, I selected out something, filtered something, counted some village by wall type, group by village, calculated percentages, and all these things gives us a small data frame of village, responded wall types, numbers, and percentage. See, it's so easy. I just want, so that whole data frame became a small thing which can be plotted in a bar plot. So I can use this to create a bar plot in the same way. Okay, new thing here is percent wall type. It's the new data frame. Ggplot, it gives aesthetics, village, XY. Fill is, you know that fill means what fill you want to use for coloring. Then bar graph, there's state identity position dots. It has to do with the position of the graph. And again, after that, again, you are layering labs. Labs mean labels, title, fill, XY. So you are layering one by one, like plus sign and new command. So all these commands will produce the graph, which is a bit more improved. And you can keep on piling up things, like you can do some new things. You can change the theme. So theme is a command for changing theme black and white. So it's a command. You can use some user different themes also. It changed the theme to a say box. It's a and background is white. So like this, you can keep on layering on this graph and keep changing it. So that's the concept of layered grammar of graphics. So this is about Ggplot. So I just wanted to convey the idea of how you start with a data frame, do a lot of things step by step, and get what you want. First for data cleaning, and second for creating graphs. So these are just two concepts, which is, I think, different from other software, how we do things. In R, especially if some people are used to other, say, MATLAB or other things, other programming, you often write loops to do some big things, which sometimes take a lot of time. In R, especially when working with tidyverse and Ggplot, and we avoid, and we kind of do not like writing for loops and all. There are more elegant way of doing things like this way, which avoids writing a lot of loops and all, which is sometimes inefficient. And this is the idea, like we do things layer by layer, step by step, and also for data cleaning, and both for data cleaning and for plotting. So both this, especially this data frame structure and Ggplot idea of plotting things works really well together. So this is about this idea, but I really recommend you to go through this data carpentry tools. Why I recommend data carpentry is it's also I'm not associated with them as an instructor. I'm just using their material just because I'm too lazy to create my own. And also they have, as I mentioned in R, they also follow the open source and policy, so I can use their license as their license terms as long as I mention their name. And I attended some of their sessions, which are really great. And thing is that those things are designed by that social scientists, because they understand how we perceive things. Like we do not really want to be a super programmer or something. We just want to get our mundane things done elegantly and efficiently. So this might help. And I think I just hope that despite all this, I think I do not think that I could explain which commands work how, but I just hope, which my main goal was just to show the idea of how we can do things by layer, both for plotting and data cleaning. So having said this, I just stop on this part of R, which is analysis, plotting, and things. And I just wanted to show you another cool feature called Markdown, which actually is very relevant to the next program we have today, I think about LaTeX. I'm not sure, is the next program is on about LaTeX?
Yes,
Yeah,
it is.
Yeah, so R actually has an implementation of or extension of LaTeX here. So this command, these files we are writing for our commands and comments, this comments does nothing here, right? This just helps people to understand the code. Here this comments does nothing. But and these are called .r file. But there's one more type of file called RMD file, R Markdown. Here you can write. So it asked me whether I want to create new document. Say let's create PDF. Let's show my slides, how I created my slides. What's her name? Need to save it. Test Markdown, I just give. Okay, so it says our workshop, and it actually already has some test data. So we just wanted to show you things. So here, this is different than this .r file. Here we only have commands, R codes, which run and create some analysis and create some variables or graphs, and comments does not do anything other than making you help you understand. But here we actually write as we write in a report. Like this is actually a header. This is not a comment. Here it's a header for a report. This is report's title, author. It asks me what PDF, whether we want a PDF. Then we are writing as if we are writing in LaTeX, but less commands. So these are like, this will appear in a report. Then inside something small. So when we want to create a graph, here we'll slip in small R codes like this. This will run and create something, whatever output it gives here or plots here, it will appear inside the report. So it's something like called, it appears in Jupyter Notebook when people work in Python. The idea is similar. So another including plots. So this thing, so plot pressure. So this is a data plot pressure, actually temperature and what air pressure it plots. This plot will appear in this report because it so you can run text. So imagine a Word file. There you just need to copy paste a image you created somewhere else, right? Maybe from Excel or somewhere. But here things will be done directly. So let's run. It actually gives us an example by default. Let's run this. It's called knitting, like we create some sweaters and all. Basically, we need text and code to create a data. So you can create HTML, PDFs. Let's create PDF. So for PDF, you need to have LaTeX installed. Actually, it is using LaTeX to generate this. So the package is called Knitter. You need to install a package called Knitter to use this feature. So see, it's our workshop. The name I gave. It's like a PDF file. It is giving some results that summary comes. First gives it. It is giving the plot we generated, like this code generates pressure. So likewise, you can, and this is like simple text. So you can write simple text, and yeah, in between you put some codes which creates plots, and you run the whole thing, and you get the results as a report. So it is an improvement from LaTeX actually, in the sense that in the LaTeX, you still your report will be produced. It's definitely an improvement, say from work only on workflow. Word has their own benefit. I don't want to disparage, but the idea is reproducibility. But in LaTeX is better than Word. You can reproduce the report by just by one click, but still you need 2 clicks there. Suppose for creating the LaTeX document, you need your graphs, right? The graphs is created by R or MATLAB or whatever. Then you need to click it there. You need to change it there. Then again click LaTeX to run for the to run and get the PDF. Here it's just one. So everything is integrated, analysis and reporting. So this idea is cool. That's how although my slides, I did not fully exploit its powers. It's actually very powerful, and it create uh, lot of good looking slides. Although my slides do not look good, still I created using this only. So you see that our file name is different, RMD file. Other files are R files. So for my slides, you can also create slides similar. So I put some title. So this means a new slide heading. Then these are Markdown syntax. These are like bullet points. So it is writing. So if I run this, it will give me those slides. So I really use Markdown a lot to report my work. So this PDF slides are coming out from this code. Although this slide does not have any R code because it was mostly text. But if you wanted to some graph and all, you can insert, say, insert R code chunk. You can actually put, nowadays you can put Python also together here, but it's, so here you can get, if you want to see, let me get the date graphs I created here. So let me get this. I need library here, tidyverse. I need the data which is in interviews plotting. Then what was the graph here? So this point graph, right? No, let's get a better graph. The color graph. Count this graph. So if I wanted to get a new slide, a graph from example graph. This is a slide heading and this graph. Now it should appear in my slide. Okay, the problem is, okay, I need to put these messages off. Message false. Warning false. Echo false. So these are some comments required for there. Just to put those ASCII messages, I just need the graph, not the code to be reproduced. Oh, sorry, I'm not here. Yeah, so these graphs appear here. like after these slides. So this way you can integrate your analysis and writing in the same place. Yeah, so I just wanted to show some of the things that might encourage or interest people to start using R. So I hope that I have been successful at some point. Although I try to analyze, I try to show some codes on the way, which were in a bit complex if you are new to R. But I think I tried to make the point that about the process of data cleaning and layout grammar of graphics, not the commands themselves. So in with this, I stop, but I really encourage you to use the resources which will help people best if they work through it on their own. Yeah, this is the website datacarpentry.org. I'll just put it in chat. So you can find resources for things other than R also in there, and sometimes you can find resources in R in your top discipline if they have developed it. But yeah, I'm open to any questions. I stop my presentation here.
Thank you, sir. Now we invite questions from our participants. The questions can be posted on the chat box of the Google Meet interface, or instead you can unmute yourself, switch on your video, and ask the speaker directly. And we urge you to keep your questions brief, precise, and to the point. We haven't received any questions. In the meanwhile, I'd like to ask one actually, if you don't mind.
Yeah.
Before the practical session, actually, we had a discussion which was put on hold regarding the pecuniary nature of our studio environment. I was wondering if you could elucidate further on how using free and open source environment or GNU license projects could empower researchers, I mean, especially in the developing world. And do you think whether it's a good idea to rely entirely on free and open source? We have received actually 2 questions, so I think we'll better go to the questions of the participants first. There is one by Mr. Tosifur Rahman, who has asked, can you tell something about looping when there are 4 or 5 conditions? I think you can see the questions in the chat box.
Yes. Okay. So yeah, do you mean in the same in the way that we write for loops like nested loops? Say one inside other. Say I loop from I from 1 to 10, then inside I j from 1 to 5, like inside that. So there are so many loops inside, so it becomes really bad. So 4-5 condition, it becomes exponentially that way. Or you just yeah, do you mean that question? That for me, like I used to write loops, and which things become really bad. Then I found a way, especially using tidyverse. I avoid writing loops mostly. Mostly, if you see things like group by and ungroup, I used. It's called divide and conquer. So you basically avoid writing loops mostly. So it's again opinionated. Like
Hello, Kirakto.
yeah,
Uh, When means I have using loop when there means I use suppose a simulation. In place of simulation, to write a function, I have to in my suppose I have a function with 4 to 5 conditions.
Okay.
Then I have to loop it. At that condition, I
Okay.
have to
So
write
there is one more use.
3
So your
conditions.
problem with looping is the hello is the problem with looping, is the problem with looping is
Hello.
due to performance efficiency issue.
Hello.
So as a sensor in that, I think there's a problem with the audio.
Okay, for Mr. Tosikur Rahman, Mr. Bora has provided an answer. If a problem with too many nested loops in simulation, then you can explore high performance computing. And we have one more question from Mr. Dhruvajuti Porgohai. Is there any package for analysis of bibliographic data?
Oh, I'm not aware of, like, I did not do any meta-analysis or something like that, but yeah, I have not done meta-analysis using R, if you mean that. But if you mean using bibliography in R Markdown or something, you can use.
There is one more question from Ms. Padmakshi Katote. Are SPSS packages not required if using R computing in social sciences?
Yeah, there will be something equivalent to SPSS. I actually remember using SPSS long time back, but I found equivalent things in R, so I never looked back to SPSS. So, but there are some things sometimes, especially using in data cleaning, I prefer to use SPSS if I have the license. Yeah, so in most of the SPSS stuff, there will be something in R that does the similar things you are trying to do. So you need to just it depends on your use you are looking for. You'll find you need to just figure out what you are trying to do, and
All right, we seem to have no further questions. We have had actually some very stimulating discussions. I think we all are trying to get acclimatized to the onslaught of new and fresh information today. As Mr. Bora has agreed to share his email ID with us, participants can write to him if they have any queries, or you may reach out to the wider R community in forums in Stack Overflow. Or instead, you can reach us, the organizers, via Google Classroom, and we will forward your queries to Mr. Bora. So today, Mr. Bora demonstrated how to handle large files of data using R and RStudio environment. As he mentioned, the crux of the exercise was not to teach R, but to rather motivate researchers to use R for its experience, workflow, and most crucially, as a respite from the mundane and repetitive nature of handling data, not to mention how it saves time and energy. The hands-on approach actually provided a lot of context for many of us thinking of switching to the R environment. I believe our participants have greatly benefited from Mr. Bora's expertise and his crisp, lucid explanations. And as I have mentioned before, perhaps a bit too many times, the free and open source nature of R and RStudio will be of great use to many of us. Today's session added a different and distinct flavor to the ongoing workshop. considering the cross-disciplinary nature of the workshop, I hope many of our participants from different disciplines will be able to incorporate many of the things discussed today in their repertoire of research. So now we are almost reaching the end of today's session. But before we conclude, I'd like to request all the participants to switch on their videos for a while so that we can take a group photograph with today's speaker. Dr. Pankaj Bora or Dr. Anupam Chanda, if you do the honors.
Yes, yes, I will take the photo. Just a minute, participants. Thank you all.
All right. Thank you, Dr. Chanda. Mr. Bora, on behalf of the entire Bahana College team, I thank you and I wish you all the best for your doctoral thesis and your future endeavors. And we hope you are open to the idea of future collaborations and inputs with us. With this, I declare today's morning session to have concluded. But before we go, I must mention that the code for today's session is India, INDIA. I repeat, the code for today's session is India. And please stay tuned for the afternoon session. And thank you. Please join us again.